Okay, let's see the solution of test 20. Question is a resistor, a capacitor, and a switch are connected in serial with a DC source. Initially, there is no charge on the capacitor. When the switch is closed, the voltage across the resistor will be 1. Increase, 2. Decrease, 3. Remain constant, or 4. More information need. Okay, this question is quite simple. We have a resistor connect with a capacitor in series, and then connect to a voltage source and a switch like this. And they say that initially there is no charge on the capacitor. Charge on the capacitor is 0. And then we close the switch. And once we close the switch, the DC source will the charge will move from the DC source, pass through the resistance, and go to the capacitor, and the positive charge start to pile up on the positive plate, and the negative charge start to pile up on the negative plate, and then the charge move back to the resistor to complete the circuit. Okay. Since initially there is no charge on the capacitor, it means that the voltage across the capacitor at time t equal to 0 is 0, right? Because by definition we have that C equal to Q over V, which means that V is equal to Q over C. And since Q is 0 initially, it means that V is 0 initially. Okay. And we must have that if the potential difference, the potential of the potential difference across the battery is V. Okay. We must have that at initial time, the voltage across the resistor must equal to V, right? Now, when the charge pile up on the capacitor, so it means that the charge on the capacitor is not 0. Okay, so we must have that when T is larger than 0, Q is larger than 0, which means that Vc is larger than 0, right? But we know that the total potential, the potential difference across R plus the potential difference across V must equal to the potential difference across the source. So it means that when Vc is not 0, when the charge pile up on the plate of the capacitor, it means that Vr must decrease. So Vr plus Vc must equal to V. So we must have that Vr is less than V. Okay, and you can see that when the charge pile up on the capacitor, the voltage across the capacitor will increase, and the voltage across the resistance will decrease, and until the voltage across the capacitor is equal to the voltage difference across the battery, and then the charge will stop pile up on the capacitor, and the voltage across R is 0. And this is reasonable because at equilibrium, when there is no charge move to the capacitor, it means that there is no current pass through the resistor. And from Ohm's law, we know that the voltage difference across the resistor will become 0. So it means that the voltage across R at the starting point is equal to V, and then it will decrease to 0 when the capacitor is full.